All right, kids, this is phase homework number 4. This is the last one. This one is actually pretty simple to do. Below is the phase diagram for water. And please note that the pressure is in atmospheres, not kilopascal. So here's your picture. See it? Same basic picture. Let's go through this diagram really quick without worrying too much about things. The pressure is in atmospheres. 1 atmosphere is normal pressure. We have this dotted line that goes all the way across, right? That's normal pressure. That's called the normal boiling point for water because it crosses the curve at 100 degrees centigrade. This is called the normal freezing point for water because it crosses standard pressure and 0 degrees centigrade. That's what we call the triple point. That's the point where you can have solids, liquids, and gases all at the same time. And then very much out of sync. Look, from here is 0 to 100, and then this little bit is 100 to 379. That's crazy. And also, this goes from, look, all the way up to 1, and then from here, 217, right? It's not really in sync, but there's another point up here called the critical point. Okay? Let's talk about what's going on in this diagram. You're supposed to redraw the whole thing. You have to label the triple point and call it TP. Label the critical point CP. The normal freezing point, which is also the normal melting point. The normal boiling point, which is a normal condensing point. And label the 3 sections, solid, liquid, and gas. So let's do that now. We start right here. This is freezing. Below this temperature, down here, this is going to be frozen. So this is the solid section, all in here. Anywhere in this whole zone is solid. Now, if you're water, and you are, because this is the diagram for water, between the freezing or melting point and the boiling point, all in here, you're going to be a liquid. You're going to be a liquid up here, and you're going to be a liquid over here. So everywhere in here is liquid. Here's the normal boiling point. Once you're at normal pressure and you hit 100 degrees centigrade, you're at the boiling point. From here up, this way, and this way, this is all the gas phase. It's even gas down here. All this down here is gas. All this is gas, all this is liquid, and solids tucked in the corner. So you find any point of pressure and temperature, look at the lines and you'll know you're either a solid, liquid, or gas. Now, how are you going to remember that? We'll use this normal pressure. There's the freezing and melting point, and there's the boil. In between melting and boiling, that's the liquid. Below that's the solid, and above that's the gas. Now you have to, number 6, 7, and 8, once you draw this picture, you're going to have to draw arrows. Now, freezing is when a liquid becomes a solid. Freezing happens all across this line. This line are all of the freezing points or all of the melting points for water at any pressure that we have. All these different pressures, and these are all the different temperatures that we're going to have. That's going to where freezing occurs. So it says what's freezing and melting. Melting goes the other way. Melting, melting, melting. But they go across this line. The next thing it says, sublimation and deposition. Now, sublimation is when a solid becomes a gas. So that would be sublimation. And deposition is when a gas becomes a solid. So there's not a lot of room, but this whole section right here, from here to here, that's the sublimation deposition curve. Now, as far as the next one, which is vaporization and condensing or boiling, this is the curve, but only up to the triple point. Going this way, we have boiling or vaporization. Going this way, vaporization. Going this way, vaporization. But going this way, we have condensing, and even down here, that would be condensing, gas to liquid phase. This curve represents all of the boiling points at all of the pressures. This line represents the melting and freezing point at all of the temperatures and all of the pressures. And that's it.